Hello everyone, welcome to this online course on manufacturing processes. I am Kishore Kumar, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So we are discussing welding for last 6-7 lecture. Different welding processes we have discussed. Also, we classified in detail welding processes and then we took welding processes one by one. Today most probably will be the last lecture on this welding processes. So two processes are left as I said in last lecture. One is brazing and one is soldering, and of course welding defects are there. So in today's lecture we are going to discuss this one. So as I said, today we are going to discuss about the welding defects, different welding defects, especially the most important one, which is very dangerous, that need to be taken care during the welding. And then we'll see two special welding processes that which is very important. One is brazing and another one is soldering. So we'll see first why these two processes are required. If we are not using these two processes, then what will happen? And also we'll see what are their major applications where these two processes are being generally used. So we are starting with the welding defects. Okay, now. So we have not taken all the welding defects. Actually, we have taken few of the most important defects. Most important in the sense means these defects that need to be removed during the welding, need to be taken care, so that once the welding process is completed, it shouldn't come over there. The first one is a porosity. So how it happens actually? Porosity means a small holes or voids will be there on the welded structure wherever we have done the welding. We know that when a material is being melted, suppose this is in solid state, so it is reacting with the environment. Okay, depending upon its nature, its reactivity will be there. Okay, now. But if this same material is melted, once it will liquid state, so its affinity towards reaction will increase. When materials are in liquid state, their affinity towards reaction generally increase. Same thing happens in welding also. In casting already we have seen. So what happens when we are welding two parts? Suppose these two sections we are welding together. So what we are doing, actually we are melting this section where we have to do the welding. So once it will be in molten phase, once it will be in liquid state, its affinity towards oxygen will increase. So what will happen? Whatever the gases will be there, this atmospheric gases will be there. In that, it will mix with this liquid or molten metal. Okay, now, and it will be trapped over there. That is not only the case. What will other things are also there? For example, it is written presence of a small voids, as I told, in metal found by gases entrapped during the solidification. So once it will react or it will be trapped over there and solidification is completed after welding, then what will happen? It will be entrapped over there, and once it will come out, it will create a small voids over there on the welded part wherever we have done the welding. So what is the reason for this one? The reason for this one is inclusion of atmospheric gases. Now the question will be, when it was in solid state, why it was not there? Yeah, of course it was there, but its affinity was less as compared to when the material is in liquid state. So this inclusion of atmospheric gases, sulfur in the weld metal, whatever the material that we are using, in that if sulfur is there, then that also will create this porosity. It will be trapped over there. And of course contamination, if contamination is there on the surfaces, means if you are doing the welding and not properly clean the surface before joining or before welding, then also these contaminants will be there entrapped in the form of, and once welding will be completed and once it will solidify over there, it will be trapped over there, and finally it will appear in the form of a small voids on the surface, which is known as porosity. So what we have to do, how can we, it can be stopped, or how we can avoid this porosity in welded structure? First thing that is there in our hand that we can do very easily is, whatever the parts we are going to weld, first we need to clean those parts properly. If it is cleaned properly, then of course there will be no problem. So that will be not entrapped over there. Another thing is that contamination, sorry, this entrapment of gases. For that, what we can do, we can do welding in a shielded area. Shielded area means area or the lab where there is no chances of entrapment. I mean, it is not interacting with the atmospheric air. It will not interact over there. So obviously there will be no reaction or entrapment of gases during the welding. So that we can avoid in that way. Another thing is shrinkage voids. Yes, it is there. Everybody knows that if you are doing the welding, suppose I'm doing welding here, so here the it is in molten phase, so temperature is high. Here it is not in molten phase, it's in solid state, so temperature is different. What will happen? Actually, there will be thermal gradient over there. Means as we are moving here to here, temperature is decreasing. So what is happening with distance? There is thermal gradient with dt upon dx. If this length we are taking this x-axis. So because of thermal gradient, what will happen? Cavities formed by shrinkage during the solidification. So there will be cavity formation, means cavity will form over there. Both of the cavity type defects are similar to the defects. Yeah, of course, just like casting. So because of this shrinkage during the welding, or sorry, during the solidification, cavities are being formed, which is known as shrinkage voids. That also easily can be removed. What we'll do before welding, we have to do the preheating of the workpiece. Okay, na. So many other ways are there through which we can avoid this defect. Another one is solid inclusions. That is also very difficult to control. Suppose we are doing a welding and we are using flux over there. So what happens? That flux will be melted, and sometime what happens? That molten flux will be mixed with the molten metal that we are welding together, and it will go inside the welded structure. So what will happen once welding will be completed? That solid inclusion will remain over there, and it will appear in the form of defect. So this non-metallic solid particles, what this non-metallic solid particles, just like flux in the arc welding. Okay, metallic oxides in aluminum, as I said at the starting in the last lecture, I told you aluminum it's very difficult metal to weld because once temperature will increase, oxide will start to form. So if those oxides are entrapped over there in the molten area or the part we are welding, or the flux if we are doing arc welding, that is there entrapped over there, finally it will appear in the form of solid inclusions. The defect class that we have taken is incomplete fusion. Incomplete fusion means heat were not sufficient to melt all the part, or the thickness of the material that we are welding together, it was more. So what happened? Penetration was not sufficient so that it will not reach to the bottom. So some sections of the part that we are welding will remain all unwelded, or it will not be fused properly. This is known as incomplete fusion. So we can see here if we are doing butt welding, so we can see here we are doing welding, but this section has been not fused together. Means heat was not sufficient to melt this area so that there is no welding in this part. Similarly, if this T shaped are there, so at the corner you can see here also there is incomplete fusion. Means fusion is, or the whatever the heat we provided to fuse it, that was not sufficient. So here also there is not complete fusion. There also you can see if L shape we are generating, this is the one plate and this is the another. So at this section, you can see it couldn't melt the material in that section, or you can say fusion was not sufficient. Okay, now so this is known as incomplete fusion. So how we can rectify this one? Of course, we'll take care the heat input, and if the thickness is more, then the groove we generally use to prepare so that penetration will be sufficient and it will reach to the bottom. So there will be no section left over there which is not fused together. Through diagram we can see this is a perfect welding. Perfect welding means there is no defect. So you can see fusion is up to bottom, there is no problem, and this shape is the ideal shape, means nothing is there is no defect. But just see this one, this is known as undercut. So what has happened, just nearby this welded area there is undercut, but this section has been removed. Means it is melted and it has been removed. It may be happen because of the many reasons. Okay, here also you can see there is underfill. Means what, suppose the filler we are using, it was not sufficient to completely fill the part where we are doing the welding. So there you can see it should be ideally like this, but you can see there is void in this area since it is not properly filled. Here also this there is overlap. Over means whatever the deposition is, it has not only filled the part where we have to do the welding, rather it has gone in other sections also. That's so it will appear like this. Ideally it should be like this, but look, it is looking like this. This is known as overlap. Different kind of cracks can be generated. It may be surface cracks, or internally also there may be cracks. What is the reason behind? The many reasons are there, but one of the prominent reason is, as I said at the starting, during the welding there will be thermal gradient. Thermal gradient means heat dissipation, or will not be same from all sections of the part that we are welding together, and because of that there will be cracks. Okay, now it may be internal, it may be on the surface. So different cracks are there. So you can see here the crack is will inside, here the cracks are, here the cracks are. That is very actually dangerous. So that also we need to take in care. So these are the defects which generally, that the most important defects will generally appear during the welding. Next, as I said, this brazing process and this soldering will take this one. These are, at the starting I told, these are the special welding processes. The special welding processes means why these processes are being used. It's very important to understand. So we are going to understand why these processes are required. Suppose I have a plate, this one plate, okay, now this P1 plate and this is the P2 plate I have to weld together. So one thing is very important to understand. Whenever we do welding of two parts, joining two parts together, it's very important for these two parts should have property, or there should be compatibility between them. Compatibility means there should be mixability, means these two metals should be mixable with each other. If these two metals are not mixable with each other, there will be very difficulty. They will be very difficult to weld together. So many materials are like this. If two materials we are going to weld together and they are not mixable with each other, they are not compatible with each other, it is very difficult to weld. So how to weld those two kind of materials? So example, if example I have to take, so iron is there, is one of those, and then silver is there, iron and silver. It is very difficult to weld because they are not mixable with each other. So if I have to weld this kind of material, what I have to do? I have to look for a third material which is known as filler, just like a sandwich. Okay, now. So in sandwich, what happens? Two breads will be there, and in between there will be a filler. Similarly, here two materials. Suppose both my palm I have to join together, but these two are having completely different nature. Means they are not mixable with each other. If these two are not mixable with each other, then of course it will not be welded directly. So what generally we do, we bring a third material in the form of filler. So that third material which is coming, it will be mixable with this palm, and it will be of course mixable with this palm. Okay, now see, if this third material or the filler is mixable with both separately. So what will happen? Once we will put this inside these two or in between these two, then these two parts will be joined together. It's a common thing. Suppose just like a common friend. Suppose this is A, this is B, and this is C. These two people are not friend with each other, but B is friend with A and C is friend with A. Then what will happen? This common friend, because of this common friend, these two will become friend. Okay, now because it will come in between these two. Similarly, although these two are not mixable with each other, but a filler suppose we are bringing, and this filler is mixable with this one as well as this one. So what will happen? Once it will come in between, so it will act like a filler. So it will join with this one, it will join with this one, and in that way these two will be joined together. This is the basic fundamental behind these two processes in both the processes. So now, depending upon what filler, what material we are going to use, depending upon that, these two processes are there. If copper we are using as a filler or its alloy, it is known as brazing operation. But if tin is being used as a filler, then it is known as soldering operation. So depending upon the filler, what kind of filler we are going to use, different names has been given. Another very important thing that need to be considered is that filler material that we use in these two processes, that will be in molten phase, means it will be melted over there, and because of the capillarity, it will make sure that the part that we are going to join, two parts we are going to join, that filler will cover the whole area, nothing will be left. Okay, now, so that there will be complete joining. The whole part will be joined together. So now we'll see it is a joining process in which a filler metal is melted. Yes, filler metal is melted and distributed by capillary action, capillarity between the fairing or the parts that we are going to join. Surfaces of the metal parts being joined. Base material doesn't melt. That is the biggest advantage of this process. Base material will not be melted. Which one will be melted? Base material will remain in its solid state. The filler that we are using, it will be melted. That's why sometimes this process is known as solid liquid process. Solid liquid process. Solid liquid process means the base metal that we are joining together, they are in their solid state, but the filler that we are using, it is in liquid state. So sometimes it is known as solid liquid process. In brazing, the filler metal has a melting temperature, that is liquidus, above 450 degrees centigrade. As I told, we are using copper as a filler, and we know the melting temperature of copper is 10,1083 degrees centigrade approximately. So obviously its temperature will be more than 40 degrees, 450 degrees centigrade. That is the one of the way of differentiation between these two processes. Melting temperature is to melt the filler metal is more than 450 degrees centigrade, then it is known as brazing. And if it is less than this one, it is known as soldering. But below the melting point, that is solidus of the base metal to be joined. Yeah, obviously. Brazing can be used to join a large variety of dissimilar materials. Yes, that is the biggest advantage. Anyway, we have already discussed. These are the two dissimilar materials. Not only dissimilarity is there, they are unmixable with each other. But although they are unmixable, but because of use of a third party, means third filler in between them, easily we can build these two parts. And also the property of the base metal will not be affected because they are not melted over there. Only filler is being melted. Okay. So brazing can be used to dissimilar metals. Pieces of different thickness can be joined together. This is the another advantage of this process. It doesn't matter what is the thickness of this one and what is the thickness of this one. Although they have a different thickness, easily can be joined by this process. Complex and multi-component assemblies can be economically fabricated with the help of brazing. Yes, even the complexity is there in the material. Easily we can join these two parts. Thin walled tubes and light tube sheet metal assemblies not joinable by other welding processes can be joined by this brazing process. These are all the advantages of this process, which couldn't welded by the gas metal. Inaccessible joint areas. Yes, many areas are there in welding. If a very complicated shape is there, that suppose I have to do a welding in an area or section which is very difficult to weld by other processes, but with the help of this one we can do. Why? Because the filler we can melt, and once it will liquid state, liquid can reach everywhere. It doesn't matter how complicated the shape is, how intricate the shape is, because liquid can easily flow from one point to another. What we have to keep in our mind, we just have to increase the velocity. So wherever the area we want this liquid to reach, obviously it will reach. Just like casting. In casting, why intricate shape is possible? Because the metal is in liquid state. Once it is in liquid state, it can reach at any section. What we have to keep in mind, that the pressure or whatever the velocity is required to reach over there, that should be there with the liquid. Similarly here, as in brazing, the material or the filler we are using, two parts we have to weld. What we have to keep in mind, whatever the filler we are using, that should have proper capillary action, so that it should reach each and every section where we have to do the welding. So even the complicated shape is there where other processes are not able to weld the parts together. With the help of this process, easily we can weld these two parts. That has been given. Even the inaccessible joint areas which couldn't be welded by the gas metal or the gas tungsten arc, spot or seam welding can be welded by brazing. So these are the advantages of this process. So this process mostly have advantage only. Okay, now rarely there is disadvantage. Disadvantage maybe that joining or the strength will not be that strong if we will compare with all the other welding processes. Besides that, there is no disadvantage of this process. Next is soldering. As I told, depending upon what is the melting temperature of the filler or the filler that we are using, if it is below 450 degrees centigrade, so obviously if tin we are using as a filler, so obviously its melting temperature is less than 450 degrees centigrade. So this is one of the criteria to differentiate these two process, soldering and brazing. But the basic fundamental, what is the basic fundamental why these two processes are being used? That is because the two material that we have to weld together, they are not mixable with each other. Means there is no compatibility between these two materials, and if there is no compatibility, there is no mixability, it's very difficult to weld. Okay na? So what we have to do for that, we have to bring a filler, okay na, or third material, just like a sandwich, and that material we are bringing as a filler, it is compatible with the both parts that we are going to weld together. So once it will come with the capillary, it will reach each and every section we have to do the welding. Now, depending upon what is the nature of the filler that we are using, it is divided in two parts. If copper or silver we are using, it is known as brazing. Or other way is also there. If the melting temperature or the filler that we are using, so if the melting temperature of that one is more than 450 degrees centigrade, so if copper we are using, obviously it is having high melting temperature, approximately 1083 degrees centigrade. So it comes under the category of brazing. But if it is less than this one, means 450 degrees centigrade, that is the temperature, then it is known as soldering operation. And also filler here used is tin. Okay. So soldering is similar to brazing and can be defined as a joining process in which a filler metal with melting point not exceeding 450 degrees centigrade is melted and distributed by capillary. This is very, very important as it is in liquid state. So because of the capillary action, it should reach each and every section where we have to do the welding. That is the reason this process is so beautiful, that even the parts which are very difficult to weld, means it's a very complicated or intricate joining is there where it's not possible to weld by other processes. But as here filler can reach as it is in liquid state, so it make it possible to weld even the intricate shape. Okay, na? So between the faying surfaces of the metal parts to be joined together. In brazing, as we have seen, no melting of the base metal. Here also, there will be no melting of the base metal. Okay, if there is no melting of the base metal, no need to tell, not much property of the base metal is going to be affected by the welding. This is not the case with the other welding processes. If melting is there, especially in fusion welding and melt based processes, because of the melting, if it is melted, obviously it is going to be solidified. And when there will be solidification, a lot of defects are going to come into picture. Okay, especially the cracks. But this is not the case here because parent metals are not going to be melted. Okay, now so if there is no melting over there, so most of the defect which generally is being encountered during the melt based processes or fusion based processes is not going to happen in this. So this is the major advantage of this process. But the filler metal waits and combines with the base metal to form a metallurgical bond. Of course, filler metal called solder. Okay, here in soldering, whatever the filler metal, the technical name is known as solder, is added to the joint which distributes itself between the closely fitting parts. Yeah. So now it may be tin or it may be lead. Okay, depending upon what material we are going to build. So this solder may be tin or lead or it's alloy. Tin is chemically active at soldering temperatures and promotes the wetting action required for the successful joining. As I said, tin is generally preferable. What is the reason? It activates at soldering temperature. The temperature which generally is used during the it activates and promotes the wetting action. Means the faying surfaces are there, so it will wet the whole part over there wherever we are going to do the welding. That's why this is more preferable. Tin is more preferable during the soldering process. Okay, so we'll stop this lecture here. So our welding section is completed. Now in this course, only one section is left, and that one is metal forming. So we'll start metal forming in the next lecture. So today we are stopping this lecture here. Thank you.